Hello and welcome to today's lesson. In today's lesson, we shall be discussing simultaneous equations, and more specifically, we shall be solving simultaneous equation using the elimination method. Let's get started. This is your instructor, Mr. Alfred Gordon. Stay with me. Now, our learning indicator for today's lesson is, in today's lesson, we will analyze two linear equations in two variables and solve them using the elimination method. What is simultaneous equation? Now, a simultaneous equation is a set of two or more equations with the same variables which are solved together to find common values of the variables. So when we have two or more equations and then they have the same variables and then we have to solve them to find some common values that will satisfy both equations, then we have a simultaneous equation. Now the elimination method we shall use today. Now the elimination method is a technique for solving simultaneous equations by eliminating one variable, leaving a single equation in the other variable. So here we shall eliminate one or more of the variables so that we have a single equation that contains only a single variable, and that we will be able to solve that first. Okay, now the steps that we shall use for the elimination methods are: first, we shall arrange both equations in standard form, that is in the form ax plus by is equal to c. So for instance, if we already have this to be 2x plus 3y is equal to 4, then this is already arranged in the standard form. Okay, however, if we have an equation of the form, say 2x is equal to y plus 5, now this is not in the standard form we are looking out for, so we shall arrange such an equation in the form 2x minus y is equal to 5. So this is the kind of arrangement we are talking about here. Now the next thing to do here is that we multiply one or both equations by suitable numbers so that the coefficients of one variable becomes equal or negatives. Okay, now this I will say is optional. Okay, so this is optional. Okay, optional. And then the reason I'm saying this is that sometimes you could find an equation where the coefficients of the variables are already the same. For instance, when we consider this to be equation 1 and this to be equation 2. Now looking here, the x variable has the same coefficient. So here we can refuse not to multiply both equations by a number to make the coefficients the same because they are already the same. Okay. Now the next thing that you should also pay attention to is this step 3. We add or subtract the equations to eliminate one variable. So here you have two things to do. Here is either we add or we subtract. So I will say this. Now whenever we find that the variables have the same coefficients and then meaning they have the same sign. Okay, so if they have the same coefficients, then they have the same sign. So it's either they are positive, positive. So when they are positive, positive, then we subtract the two equations. And when they are negative, negative, meaning they have the same sign. When they have the same sign, we also subtract. However, when they have opposite signs, then we add. Okay, so I think we will find that in the examples we shall discuss. Now solving the resulting single variable equation. Okay, so that's the next thing. Then substitute the value back into one of the original equations to find the other variable, and then we can do the last check to check the solution by substituting into both equations to see if the answers really are true. Okay, so let's begin with some examples. In this example, we will be solving equations that requires basic elimination and then they have the same signs. So when they have the same signs, then what we will do here is that we will subtract the two equations. Okay, now let's try this. Solve the following system of equations using the elimination method. So let us find out if they are already arranged in the standard form we are talking about. So the standard form we were talking about was, it should be in the form ax plus by is equal to c, okay, where a, b, c are constants. So here we could find that we have 3x plus 2y is equal to 19. Perfect. We have 3x minus y is equal to 4, also in the standard form. So let's name them as our equation 1 and equation 2. So we have 3x plus 2y is equal to 19 as equation 1. And we have 3x minus y is equal to 4. So also as our equation 2. Okay, so here, this is where we check. So let us check whether a variable has the same coefficients. Okay, so looking here for x has a coefficient of 3 here and has a coefficient of 3 here, meaning x has the same coefficients in this equation. Okay, and then y does not have same coefficients. Okay, so we can think of eliminating the variable x since they have the same coefficients. And then since the coefficients are both positive, then we will subtract. So we can do equation 1 minus equation 2. Okay, so at the left side of equation 1, we have 3x plus 2y, okay, minus that of equation 2. And equation 2 here, we have 3x minus y is equal to, so it's equal to, then let's do this. It's still in the same order. Equation 1 is 19, so let's do 19, okay, minus, then let's have equation 2, which is what? 4. I have intentionally used a different color so that we see what we are doing here. So the order here should be the same. It's equation 1 minus equation 2 at the left side, equation 1 minus equation 2. Okay, so let's simplify. You have 3x, okay, plus 2y, and then this, let me change color, sorry, stay with me. We have 3x plus 2y, and then here we are expanding the bracket with a negative, so minus 3x, and we have plus y is equal to 19 minus 4 gives us 15. Okay, now we can group like terms here, so 3x minus 3x, okay, then we have plus 2y, okay, plus y is equal to 15. So 3x minus 3x gives us a 0, but 2y plus y gives us a 3y is equal to 15. Okay, and then we can divide both sides by 3. Okay, so 15 divided by 3. And here we have, this divides that 1 and 1. Okay, so y is equal to, now 15, 3 divides itself 1, it divides 15 5 times. So y is equal to 5. Okay, now that we have the value of one of the variables, now I think it is fair that we now use the value we have to find the value of the other variable. So we will substitute. So let us do this here. So substitute y is equal to 5 into equation. So here by choice, let's do equation 2. So here we have equation 2 to be 3x minus y is equal to 4. And then here we know y is 5. So we have 3x minus 5 is equal to 4. So we have 3x is equal to 4 plus 5. Okay, here I'm crossing the equal to sign. So let's go. So 3x is equal to 9. And then we divide both sides by 3. Okay, so this by 3. And then 9 divided by 3. And here we have, this divides itself 1. Okay, so x is equal to 9 divided by 3 gives us what? A 3. So we can say that the solution for the system of equations there is x is equal to 3 and y is equal to 5. So here we can do a check. So let's check this in one of the equations and see. So checking with the second equation, we have 3 into x is 3, okay, minus Now we have a 5 for y, and here we know that this times that is 9. 9 minus 5 is going to give us a 4, and this is very true, so checked. And we can verify from the other equation as 3 multiplying x is 3 minus plus 2, okay, y is 5, and this is 3 times 3 is 9, and then 2 times 5 is 10, and 10 plus 9 is 19, and this is also correct. So our solution is really very right. Let's try one more example there. So here you have to solve the system of equations using the elimination method, and let's check. Are they already in standard form? Yes, it's true, it's in standard form. So we have 9x minus 5y, okay, is equal to negative 2. So let's name this as equation 1. And we have 2x minus 5y is equal to negative 11. Okay, this as equation 2. So here, let's just check if one of the variables have the same coefficients. Yes, we could see that y has the coefficients negative 5, and y here has coefficients negative 5. So it's very careful that you check for your equations. If it happens this way, then you'll be able to follow through, okay? So since they have the same coefficients, what do? We subtract. So we are subtracting, so you can do equation 1 minus equation 2, or equation 2 minus equation 1, any of them is okay. So and in our equation 1 we have 9x minus 5y, okay, for our equation 1, minus our equation 2 we have 2x minus 5y at the left side, and this is equal to, okay, this is equal to equation 1 we have minus 2, okay, and then minus. Now in our equation 2 we have minus 11. Be very careful with the negatives. Okay, so let's continue to solve this. So here we have 9x minus 5y, and expanding our negative, okay, so expanding with the negative will give us negative 2x, okay, we have plus 5y for the left side, and here we have a minus 2, and then a negative 2 times a negative giving us a positive 11. Okay, let's continue to solve here by grouping like terms. Okay, we have this minus 5y, and here we have plus 5y is equal to, I think we can do something here. Okay, this is minus 2 plus 11, okay, which is giving us a 9, and we subtract this to get a 7yx, okay, so here is 7x, and this is giving us a 0, so this is equal to 9. So what can we say here? Then 7x is equal to 9. Divide both sides by 7. Okay, 7 divides itself, 1 divides that 1, and x is equal to, here we have a fraction of 9 on 7. So this is our value for x. Let's go ahead and find the value of the other variable y. Okay, so here we substitute, okay, so substitute x is equal to 9 on 7 into equation, okay, so which equation? Let's do into equation 2, okay, so into equation 2 we have 2x minus 5y is equal to minus 11. Okay, and then we know x to be that, so 2 into x is 9 on 7 minus 5y is equal to minus 11. So here let's do some fractions here. So 2 times 9 will give us 18, okay, on 7 minus 5y is equal to minus 11. So let's take it cool here. Okay, so here we can write this as minus 5y, okay, is equal to a minus 11, okay, minus 18 on 7, okay. Okay, so here we have a minus 5y is equal to, now a minus 11 minus 18 on 7 gives us a minus 95 on 7, okay, and then we divide both sides by minus 5, so we have minus 5y divided by minus 5, and we have minus 95 on 7, okay, let's divide that by minus 5. So here we are going to have y is equal to, so this and this are the same, so that gives us a 1. And here we are going to have this to be minus 95 on 7 divided by minus 5 will give us 19 on 7. Okay, so here we have our x to be equal to 9 on 7, and we have our y to be equal to 19 on 7. Okay, so this is the solution to our system of equations that we have above there. Now let us continue to solve other examples. So let's come here. Now here you are going to solve equations that requires basic elimination, okay, but here with opposite signs. So when they have opposite signs, then what we do here is that we add the two equations. Okay, so let's try this example here. Now we are to solve the system of equations using elimination method, and the two equations here are already arranged in the standard form, so we can go ahead and name them as our equation 1 and equation 2, right? So we have equation 1, okay, to be this, and then we have 3x, okay, minus 5y is equal to 19 as equation 2. So let's check carefully here. Now when you check the coefficients of x here, you could find that they are not the same. This is 3, this is 2, this is 3, okay? And then looking here, we have this to be plus 5, and we have this to be minus 5. Now, we could see that the coefficients have opposite signs. Yes, they are 5, 5, but the signs are opposite. So here, because they are opposite signs, okay, then we can add equation 1 to equation 2. So here we do equation 1 plus equation 2. So let's go ahead here. So what do we have in equation 1? We have 2x plus 5y, okay, plus our equation 2. So let me change color. Equation 2, we have 3x minus 5y, and this is equal to equation 1, which is 21, okay. Then let's do a plus. Then equation 2, we have a 19. So here we have added, and let's continue to simplify. So expanding the bracket will give us 2x plus 5y here, plus 3x minus 5y, okay, is equal to, now here 21 plus 19 gives us a 40. Okay, so grouping like terms on the left hand side will give us a 2x plus a 3x, okay, plus 5y minus 5y is equal to 40. So 2x plus 3x will give us a 5x, okay, and then 5y minus 5y, that is 0, is equal to 40. So here we have 5x is equal to 40. So divide both sides by 5. So divide this by 5, okay, and then 40 also divided by 5. So here 5 divides itself, 1 divides that 1. We have x is equal to 40 divided by 5. That is 5 divides itself 1 and divides 40 8 times. Okay, so we have x to be 8. And this is not the end of the job, okay? Now we have the value of x, so we need to substitute that value into one of the equations. So we substitute, okay, so substitute, okay, x is equal to 8 into, so okay, so let's do into equation 1 this time, okay, into equation 1. So equation 1 is 2x plus 5y is equal to 21. Yes, it's equal to 21. So we can do this as x is 8, so 2 times 8 plus 5y is equal to 21. So what is 2 times 8? 2 times 8 is 16, plus 5y is equal to 21. Okay, so here we have 5y is equal to 21 minus 16. And we have 5y is equal to 21 minus 16. Okay, so here, okay, so 21 minus 16 gives us a 5. Okay, and we can now divide both sides by 5. Okay, so divide this side by 5 and the other side of the equation by 5. Yeah, y is equal to, this divides 1, divides that 1. 5 divides itself, 1 divides that 1. Okay, so we have y is equal to 1. So we can see that in this we have x is equal to 8 and we have y is equal to 1. Okay, so this is the solution to the system of equations we have above there. So we have another one more example. We have opposite signs. Okay, so we have this. We have x plus y is equal to 12 as equation 1. We have x minus y is equal to 4 as equation 2. Okay, so checking the sign here, we could see the coefficients of y here is 1 and the coefficients of y here is minus 1. Here we could see they are opposite signs. So if they are opposite signs, then we can do equation 1 plus equation 2. Okay, so equation 1 we have x plus y, okay, plus equation 2 we have x minus y, and equation 1 we have 12 plus equation 2 we have 4. So x plus y, then we have plus x minus y is equal to 12 plus 4 gives us 16. Okay, so here we have grouping like terms. Yeah, we have that. We have y minus y, okay, is equal to 16. And x plus x gives us a 2x. Y minus y gives us a 0. And we have 16. So we have 2x is equal to 16. We can divide both sides by 2 here. So this by 2 and the other by 2. Okay, so like we know, yes. Now 16 divided by 2 will give us 8. Okay, so this is for the value of x. So let's go ahead and find for the value of y by doing a substitution. So by substitution or by substituting, okay, x is equal to 8 into equation. So which equation do you prefer here? I prefer equation 1 because I don't want to deal with a lot of negatives. Okay, so I have x plus y is equal to 12. And we know x to be 8. So we have 8 plus y is equal to 12. And here, y is equal to 12 minus 8. Okay, and y is equal to 12 minus 8 will give us a 4. So we can say that in this we have x is equal to 8 and we have y is equal to 4. Okay, so I'll pause this video here and then we shall continue our lesson in our next video. Thank you and have a nice day. Don't forget to like, share and subscribe to this channel.